Git works.
And then here I can set up my alternate credentials, and then I could put any username and password here that I want, and then be able to type that on the command line versus my account information that I did before. And again, we're having some very slow internet.
And there are also a number of different ways in which you can commit to the repo.
Absolutely.
For instance, Donovan could have done a Git clone.
Absolutely.
Pulled down, the empty repository, and then put the copy and pasted the files in there, and then done a push. So there's a number of different ways you can go about it, but we just want to get you familiar and show you that, hey, this is Git.
Absolutely.
This is, the standard protocol and how you operate.
Yeah, so there's no wrong way to get your code into the Git repo. Whatever commands work for you, feel free to use them. That's the mode that I go to, because if I were to clone and then sometimes clone from GitHub, you have to then copy it out of there to make sure you don't have all the other information. And I felt this way allowed me to just do a quick copy and paste, but he's absolutely right. There's no wrong way to get your code in there. I wanted to jump back to this screen while we waited for the other one to load to show you that that empty repo now has all the code in it that we want to use in the future modules to be able to continue with build. And here's where you would actually be able to set those additional credentials.
Okay.
Great. So we're ready now to kick off into the next module and actually show how we're going to build that code using our new build system.
Yeah, very cool. So we want to share with you some resources that we have, just so you're well aware of where you can learn more things about DevOps. And we want to specifically call out, Donovan already has shown us this Parts Unlimited application. Now, he pulled some custom, he had a fork of the Parts Unlimited application and did some customizations to his own repo. But that being said, there is a Microsoft-supported Parts Unlimited application and a Parts Unlimited MRP, which is fully open source, and the Parts Unlimited is the kind of all Microsoft type of app. Tied back to the Phoenix project. That's the main one I want to call out here, but there are a ton of other resources from Microsoft on helping you with DevOps.
Absolutely.
So with that, though, we want to go ahead and close out. Thanks for watching the overview, and stay tuned for the next module. Welcome back to Enabling DevOps Practices with Visual Studio Online Build. We are continuing on with the second module about build fundamentals and continuous integration. For this module, we're going to talk about first, what is continuous integration, explain that a little bit, and then snap to walking through really the fundamentals of the new build in Visual Studio Online, and end a little bit with a deeper click onto extensibility. We mentioned it briefly earlier on the module before. So first up, I want to explain a little bit about manual builds and kind of the challenges that can happen there with this. Now, typical dev, right? You're going to just ideally dev on your box and create a build. You may, manually execute a build. You may also, though, right, check into some kind of source code control, and at some point a build will pop up there, either via a manual kind of way to get it done.
Yeah, generally when you're dealing with a team that has manual builds, it's some poor sap's responsibility to go off and do the build. So he has to stop what he's doing, go inside Visual Studio, get the latest of everything, and then sit there and press Control-Shift-B or whatever his keyboard shortcut is to produce that build. And then he has to go and package it up and then copy it to some file share and then send out this huge list of emails to, hey, go get the latest version of our build. So it's very error prone, and it relies on this guy's box being perfect, right? And if that poor guy has a version of a DLL on his machine that's not on everyone else's machine, we potentially are going to have a lot of problems. So that's why we want a continuous integration on a build machine that is designed to do builds.
Yeah. So lots of delays, lots of waste when you use the lean manufacturing terms by doing manual builds, right? Especially the more manual and the more delays you have there in getting that known build, the longer it takes for the developers to develop their software, right? Because you got to have a build that other people can test and do other things against. So there's just all kinds of things here that cause slowness here. When you do continuous integration, though, things get a bit different. So the core fundamental of, I guess, the lower level of definition, or the base definition of continuous integration, would be you check in some code into source code control, and then upon that check-in, some automated process goes and fires off that build in a central location. So this is kind of the baseline definition of what I would say continuous integration is. Now, if you take a more, I'd say, conservative, or a Jez Humble kind of view of continuous integration, when you look at that definition, continuous integration is also going to include some form of automated tests happening against that build. So every time, basically, you check into mainline, right? And this is the other element of continuous integration, is you have trunk or a trunk branch, and everybody checks into that one trunk branch. It's similar in the lean manufacturing concept to kind of the Toyota production system, where there's an anon cord. And when you look at the anon cord, it's like anytime there's a problem with that line, somebody pulls the cord, and and then things stop until you get it fixed, right? Well, in a software development world, that would be kind of like your trunk branch, right? So if everybody's checking in on a regular basis into that main line trunk branch, and there's any problems with that build, then you either revert the build or you fix the build so that always that mainline trunk branch is in a good state. So there's a lot within this, but just the main thing is that you get that fundamental concept of continuous integration. You can see the contrast between manual build, create this thing, and it's this big long process, to I'm checking in code, and wow, I get a build, I get tests, and everybody kind of has access to that, right? It's a fundamental concept for a DevOps practice, and we're going to show you how to do that here using Visual Studio Online Build, or Donovan is, I guess, more correct.
Sure.
So yeah, so I guess now we can
switch already. That was
switch over.
Short, sure.
Yeah.
So we're going to pick up exactly where we left off. So we had just gotten our code into our private repo inside of Visual Studio Online, and all we have to do now is simply click on the Build tab. And what that's going to do is it's going to take us to our Build Hub, which will give us the ability to add new build definitions. We're going to quickly add a new build, and then while that build's running, I'm going to take you on a much more exhaustive tour of the system. When I click on adding a new build, I am presented a list of templates that I can choose from that already have all the necessary tasks in line that I can actually use to do a very common scenario, like, for example, build and test a Visual Studio project, or as we've been talking about the cross-platform, we also have the ability to do Xamarin or even Xcode deployments here as well, or builds.
The big thing to point out here, too, is that this is not all of the tasks.
No, yeah, good point. These are not tasks. These are actually templates. I'm glad you made that clarification. A template is a collection of tasks that are going to be able to achieve a particular goal. So, for example, we have deployment, which we'll talk about in the last module. So we have a template here that knows how to build, package, test, and even deploy a website. So it's going to be a whole series of tasks that we're going to see. So instead of me having to build the build every single time, task by task, we've given you these templates that already have a series of tasks in them to achieve a particular goal. Good clarification. So here I'm going to go ahead and click on OK. And as you'll see, these are the tasks that are actually going to be used to build our application. And as David was pointing out, there's a whole list of tasks that we can actually use to build our application. What I'm going to do here really quickly is I'm going to actually click on this Visual Studio test item, and I can see some of the different properties I have. I know for a fact that I've actually built my application specifically to have a build failure, not a build failure, but a test failure. So I'm going to go ahead and say, even if my test fails, I want you to continue with my build. So what we're going to do is we're going to see one test is going to pass and one test is going to fail, but I don't want to fail my build just because of that. And we'll come back and talk about some more of those details. All I have to do now is simply save it and give it a name, and we're going to call this .NET because we're going to do some fun stuff with Java later. And with that, I can now go ahead and queue my build. Now you'll notice I didn't install any agents, I didn't have to set any parameters, I literally just checked one checkbox letting you know that I want my test to continue even if some of them fail. And now I'm being presented a dialog box for me to queue my build. Queuing the build, you get to target a queue, and we're going to talk a little bit more about these. We have hosted queues for you inside of Azure, so you don't have to install anything. We actually have build machines ready to build your code for you, and we have them hosted. So I'm going to use that here right now. I can choose what branch of code I want to if I have multiple branches in my Git repo. And I can choose what configuration I want to build and even what platform I want to target. And I simply click on OK. Now, what we're going to do is it's going to go off right now to the cloud and find a build agent that it can use to actually build our application. And we're going to talk about how it chooses the right agent depending on what it is you're trying to build. And then here on this console, you're going to be able to see in real time the output from the agent that has been selected to do your build. So as we talked about in the overview, we don't want you to have to go hunting for your logs. As you can see, they're actually showing to you in real time so that you can monitor the build as it happens, and you can also go back in and download these should you need to. So while that build's running, let's go back and let's take a much closer look at all the different areas of our new build system. You've already seen the ability to add tasks and to be able to have our task library. We'll talk about extensibility and ways that you can get in there and make some changes or even add your own. Every one of these tasks has a series of properties on the right-hand side that allow you to go back in and customize and cater that particular task to the goal that you're trying to achieve. After the Build tab, we have what we call the Options tab. The Options tab gives me the ability to run builds in parallel. Let's say, for